teammate killed this one.
What's up, guys? My name is Trey, and today you will be taking a Python skill assessment. This short quiz is on Numpy. This video will prove very informative. What is Numpy, and why is it important in the Python machine learning stack? Numpy is a fundamental tool in the Python machine learning stack. It enables efficient operations on data structures like vectors, matrices, and tensors, which are commonly used in machine learning workflows. While not the primary focus of this book, Numpy plays a crucial role in various chapters. It provides optimized operations for handling numerical data, making it an essential library for various machine learning tasks. Explanation: Numpy is a powerful library that provides support for multidimensional arrays and efficient mathematical operations on them. It forms the basis for many other libraries in the Python machine learning ecosystem. By allowing efficient manipulation of arrays and matrices, it enhances the performance of algorithms and simplifies the implementation of complex mathematical computations often encountered in machine learning. How do you create a vector using NumPy? Provide examples of creating a vector as both a row and a column. To create a vector using NumPy, you can use the np.array function. A vector is a one-dimensional array. You can represent it either as a row or a column. Explanation: in the given code snippet, the np.array function is used to create vectors. Vector_row represents a row vector, and vector_column represents a column vector. The key idea is that a vector is essentially a one-dimensional array in NumPy, and its representation as a row or column depends on how you shape the array. How can you create a matrix using NumPy? Provide an example of creating a matrix with specific values. You can create a matrix using NumPy's np.array function with a two-dimensional array as an argument. Explanation: the provided code demonstrates how to create a matrix using NumPy. The matrix is represented as a two-dimensional array where each row corresponds to a list of values. In this example, the resulting matrix has 3 rows and 2 columns, containing values 1 and 2. What is a sparse matrix, and why might you want to use it in machine learning? A sparse matrix is a matrix in which the majority of its elements are zeros. In machine learning, sparse matrices are used to efficiently store and manipulate large datasets with many zero elements. This is particularly relevant in scenarios where data has a high dimensionality but only a few non-zero values, such as text data or recommendation systems. Explanation: sparse matrices are beneficial when working with high-dimensional data, as most of the entries are zeros. Storing and operating on these zeros is computationally expensive and memory-intensive. Sparse matrices save memory by only storing the non-zero values along with their indices, which significantly improves performance in terms of both memory consumption and computational efficiency. How can you create a sparse matrix using NumPy and SciPy? Provide an example of creating a compressed sparse row, CSR matrix. You can create a sparse matrix using the SciPy, sparse modules functions like CSR_matrix. Explanation: the code provided demonstrates how to create a sparse matrix using the compressed sparse row, CSR, format from the SciPy, sparse module. The matrix is defined with 2 non-zero values, 1 and 3, at specific positions, while the rest are zeros. By using the CSR format, only the non-zero values and their indices are stored, leading to memory and computational efficiency. What does it mean to pre-allocate a NumPy array, and why might you want to do so? Pre-allocating a NumPy array means creating an array of a specific size and possibly initializing it with certain values before using it in computations. This is done to improve code performance, memory management, and to avoid reallocation during operations. Explanation: pre-allocating arrays can be essential in optimizing code execution. It helps prevent unnecessary memory allocations and deallocations during computations, which can improve the speed and efficiency of algorithms. By specifying the size and initializing the array up front, you reduce the overhead of dynamic memory management and can use the allocated memory more effectively. How can you select specific elements or subsets of elements in a NumPy vector or matrix? Provide examples of different selection methods. You can use indexing and slicing to select specific elements or subsets of elements in NumPy arrays. Explanation: the provided code snippet demonstrates various methods of selecting elements from NumPy vectors and matrices. Indexing, slicing, and negative indexing are used to extract specific elements or subarrays. These operations allow you to manipulate data efficiently and extract the information you need for further computations. How do you describe the shape, size, and dimensions of a matrix using NumPy? Provide examples of using the attributes shape, size, and indim. You can use the shape, size, and indim attributes of a NumPy array to describe its shape, size, and number of dimensions. Explanation: the given code shows how to use the attributes shape, size, and indim to describe a matrix. Shape provides the dimensions, rows and columns. Size returns the total number of elements, and indim indicates the number of dimensions. Understanding these attributes is important for managing and manipulating arrays effectively. How can you apply a function to each element in a Numpy array? Provide examples using both the np.vectorize method and broadcasting. You can apply a function to each element of a Numpy array using the np.vectorize method or by using broadcasting. Explanation. The code provided demonstrates two ways to apply a function to each element in a Numpy array. np.vectorize is used to create a vectorized version of a function, allowing you to apply it element-wise. Alternatively, broadcasting is utilized to perform element-wise operations directly without explicitly vectorizing the function. Broadcasting is often more efficient and a preferred approach when possible. How can you find the maximum and minimum values in a Numpy array? Provide examples using the np.max and np.min methods, along with specifying the axis parameter. You can find the maximum and minimum values in a Numpy array using the np.max and np.min methods. You can also specify the axis parameter to calculate maximum and minimum values along specific axes. Explanation. The code illustrates how to use the np.max and np.min methods to find the maximum and minimum values in a Numpy array. The optional axis parameter allows you to perform these calculations along specific axes, either rows or columns. Understanding these methods and parameters is crucial for data analysis and manipulation. How can you calculate the average, variance, and standard deviation of a Numpy array? Provide examples using the np-mean, np-dvar, and np.std methods. You can calculate the average, variance, and standard deviation of a Numpy array using the np-mean, np.dvar, and np.std methods. The provided code demonstrates how to use np-mean, np-dvar, and np.std to calculate the average, variance, and standard deviation of a Numpy array. These statistical measures provide valuable insights into the distribution and characteristics of the data. Understanding these methods helps in data pre-processing and analysis. How can you reshape a Numpy array? Provide an example of reshaping a matrix into a vector and vice versa. You can reshape a Numpy array using the reshape method while specifying the desired new shape. Explanation. The code shows how to use the reshape method to change the shape of a Numpy array. In the provided examples, a matrix is reshaped into a vector and vice versa. Reshaping arrays is a useful technique when you need to transform data between different dimensions or representations. How can you concatenate two Numpy arrays? Provide examples of concatenating along both rows and columns using the np.concatenate function. You can concatenate two Numpy arrays using the np.concatenate function, specifying the arrays and the axis along which to concatenate. Explanation. The code illustrates how to use the np.concatenate function to concatenate two Numpy arrays along either rows or columns. The axis parameter determines the concatenation axis. Understanding array concatenation is important for combining and manipulating data from different sources. How can you perform element-wise arithmetic operations between two Numpy arrays? Provide examples of addition, subtraction, multiplication, division, and exponentiation. You can perform element-wise arithmetic operations between two Numpy arrays using standard arithmetic operators. Explanation. The provided code demonstrates various element-wise arithmetic operations between Numpy arrays. The arithmetic operations are applied element-wise, which means that corresponding elements from the two arrays are combined using the specified operation. Understanding element-wise operations is crucial for numerical computations in data science and machine learning. How can you apply element-wise comparison between two Numpy arrays? Provide examples of comparing for equality, greater than, and less than. You can apply element-wise comparison between two Numpy arrays using comparison operators. Explanation. The code provided demonstrates how to use comparison operators to perform element-wise comparisons between Numpy arrays. The resulting arrays contain Boolean values that indicate the outcome of the specified comparisons. Element-wise comparison is fundamental for various operations such as filtering data or creating conditional statements. How can you perform element-wise logical operations between two Numpy arrays? Provide examples of applying logical and, OR, and NOT operations. You can perform element-wise logical operations between two Numpy arrays using logical operators, AND for AND, vertical bar for OR, tilde for NOT. Explanation. The code illustrates how to use logical operators for element-wise logical operations between Numpy arrays. Logical operations are used to combine Boolean values element-wise, allowing you to create complex conditions and filter data based on logical criteria. How can you sort the elements of a Numpy array? Provide examples of sorting along different axes using the np.sort function. You can sort the elements of a Numpy array using the np.sort function, which returns a sorted copy of the array. Explanation. The code demonstrates how to use the NP sort function to sort the elements of a Numpy array along different axes. Sorting is a common operation in data analysis and manipulation, and understanding sorting methods is crucial for organizing and analyzing data effectively. How can you find the indices that would sort a NumPy array? Provide an example using the np-argsort function. You can find the indices that would sort a NumPy array using the np-argsort function. Explanation. The provided code shows how to use the np-argsort function to find the indices that would sort a NumPy array. This is useful when you want to sort an array and obtain the corresponding indices to understand the original order of elements after sorting. What is the purpose of the np.where function in Numpy? Provide an example of using it to perform conditional operations. The np.where function in NumPy is used to perform conditional operations and return elements from two arrays based on a specified condition. Explanation. The code provided demonstrates how to use the np.where function to perform conditional operations on NumPy arrays. The function returns elements from two arrays based on a specified condition. This is a powerful tool for data manipulation and creating conditional transformations of arrays. How can you perform matrix multiplication using NumPy? Provide an example using the np.dot function and the operator. You can perform matrix multiplication using the np.dot function or the operator in Numpy. Explanation. The code illustrates how to use the np.dot function and the operator to perform matrix multiplication in Numpy. Matrix multiplication is a fundamental operation in linear algebra and is widely used in various mathematical and machine learning contexts. How can you calculate the element-wise dot product between two arrays in NumPy? Provide an example using the np-multiply function. You can calculate the element-wise dot product between two arrays in NumPy using the np-multiply function. Explanation. The code demonstrates how to use the npd-multiply function to calculate the element-wise dot product between two arrays. The result is an array where each element is the product of the corresponding elements from the input arrays. This operation is important for various mathematical computations in NumPy. How do you perform matrix transposition using NumPy? Provide an example using the np.transpose function and the t attribute. You can perform matrix transposition using the np.transpose function or the t attribute of a NumPy array. Explanation. The code shows how to use the np.transpose function and the t attribute to perform matrix transposition in NumPy. Transposing a matrix flips its rows and columns, which can be useful in various mathematical operations and transformations. What is broadcasting in NumPy and why is it useful? Provide an example of how broadcasting works in arithmetic operations. Broadcasting in NumPy is a mechanism that allows element-wise operations between arrays with different shapes, making it easier to perform operations on arrays of different dimensions without explicitly resizing them. Explanation. The provided code illustrates how broadcasting works in NumPy. When performing element-wise operations between arrays with different shapes, NumPy automatically broadcasts the smaller array to match the shape of the larger array. This simplifies code and makes it more readable, as you don't need to reshape arrays explicitly. How can you handle missing or invalid data in a NumPy array? Provide examples using the np.nan value and the np-isnan function. You can handle missing or invalid data in a NumPy array using the special value np-nan, not a number, and the np-isnan function to check for it. Explanation. The code demonstrates how to use np-nan to represent missing or invalid data, and the np-isnan function to check for nan values in a NumPy array. Handling missing data is crucial for data analysis and processing, and these techniques allow you to identify and handle nan values effectively. What is the purpose of the npt concatenate function in NumPy? Provide an example of concatenating two arrays along different axes. The np concatenate function in NumPy is used to concatenate two or more arrays along a specified axis. Explanation. The code provided demonstrates how to use the np.concatenate function to concatenate two arrays along different axes. Concatenation is a common operation when combining data from multiple sources or when reshaping arrays. How can you reshape a NumPy array? Provide examples of reshaping using the .reshape method and the np.reshape function. You can reshape a Numpy array using the .reshape method or the np.reshape function. Explanation. The code illustrates how to use the .reshape method and the np.reshape function to reshape a NumPy array. Reshaping is essential for changing the dimensions of an array while keeping the same data. This operation is frequently used in data preprocessing and manipulation. How can you create a diagonal matrix from a NumPy array? Provide an example using the np-diag function. You can create a diagonal matrix from a Numpy array using the np-diag function. Explanation. The code shows how to use the np-diag function to create a diagonal matrix from a NumPy array. A diagonal matrix is a square matrix in which the elements outside the main diagonal are all zero. This operation is useful for various linear algebra calculations. How can you calculate the element-wise absolute values of a Numpy array? Provide an example using the np-abs function. You can calculate the element-wise absolute values of a Numpy array using the np-abs function. Explanation. The code demonstrates how to use the np-abs function to calculate the element-wise absolute values of a Numpy array. This is useful for various scenarios where you need to work with the magnitude of values, regardless of their sign. What is the purpose of the np-unique function in Numpy? Provide an example of using it to obtain unique values and their counts from an array. The np-unique function in Numpy is used to obtain unique values from an array along with their counts. Explanation. The code provided shows how to use the np-unique function to obtain unique values and their counts from a Numpy array. This function is useful for data exploration and analysis, allowing you to identify distinct values in an array and understand their distribution. How can you calculate the cumulative sum and cumulative product of elements in a Numpy array? Provide examples using the np.cumsum and np.cumprod functions. You can calculate the cumulative sum and cumulative product of elements in a Numpy array using the np.cumsum and np.cumprod functions. Explanation. The code demonstrates how to use the np.cumsum and np.cumprod functions to calculate the cumulative sum and cumulative product of elements in a Numpy array. These functions are useful for tracking the accumulation of values over an array and are commonly used in time series analysis and financial calculations. How can you calculate the mean, median, and mode of a Numpy array? Provide examples using the npd mean, np median, and scipy-stats mode functions. You can calculate the mean, median, and mode of a Numpy array using the np.mean, np.median, and scipy-stats.mode functions. Explanation. The code illustrates how to use the np.mean, np.median, and scipy-stats.mode functions to calculate the mean, median, and mode of a Numpy array respectively. These statistical measures provide valuable insights into the central tendency and distribution of data. How can you perform matrix multiplication between a matrix and a scalar in Numpy? Provide an example using the asterisk operator. You can perform matrix multiplication between a matrix and a scalar in Numpy using the asterisk operator. Explanation. The code provided demonstrates how to use the asterisk operator to perform matrix multiplication between a matrix and a scalar in Numpy. This operation is useful for scaling matrices and performing other arithmetic transformations. How can you find the indices of non-zero elements in a Numpy array? Provide an example using the np.nonzero function. You can find the indices of non-zero elements in a Numpy array using the np.nonzero function. Explanation. The code shows how to use the np.nonzero function to find the indices of non-zero elements in a Numpy array. This is useful for locating specific elements in an array or for identifying patterns in data. How can you calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array? Provide examples using the np.log and np-log10 functions. You can calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array using the np.log and np-log10 functions. Explanation. The code illustrates how to use the np.log and np-log10 functions to calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array. How can you calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array? Provide examples using the np.log and np-log10 functions. You can calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array using the np-log and np-log10 functions. Explanation. The code illustrates how to use the np-log and np-log10 functions to calculate the element-wise natural logarithm and base 10 logarithm of a Numpy array. These operations are essential for various mathematical transformations and data analysis tasks. How can you round the elements of a Numpy array to the nearest integer? Provide an example using the np.round function. You can round the elements of a Numpy array to that nearest integer using the np.round function. Explanation. The code demonstrates how to use the np.round function to round the elements of a Numpy array to the nearest integer. Rounding is a common operation in data analysis and manipulation, especially when dealing with numerical data. How can you perform element-wise floor division and modulo operations on a Numpy array? Provide examples using the np.floorDivide and np.mod functions. You can perform the element-wise floor division and modulo operations on a Numpy array using the np.floorDivide and np.mod functions. Explanation. The code illustrates how to use the np.floorDivide and np.mod functions to perform element-wise floor division and modulo operations on a Numpy array. These operations are useful for various mathematical computations and transformations involving integers. How can you compute the element-wise reciprocal and element-wise negative of a Numpy array? Provide examples using the np.reciprocal and np.negative functions. You can compute the element-wise reciprocal and element-wise negative of a Numpy array using the np.reciprocal and np.negative functions. Explanation. The code demonstrates how to use the np.reciprocal and np.negative functions to compute the element-wise reciprocal and element-wise negative of a Numpy array. These operations are useful for performing arithmetic transformations and computations involving reciprocals and negation. How can you find the index of the maximum and minimum values in a Numpy array? Provide examples using the np.argmax and np.argmin functions. You can find the index of the maximum and minimum values in a Numpy array using the np.argmax and np.argmin functions. Explanation. The code provides examples of how to use the np.argmax and np.argmin functions to find the index of the maximum and minimum values in a Numpy array respectively. These functions are useful for locating extreme values in data and analyzing their positions. How can you create a one-hot encoded matrix from categorical data using Numpy? Provide an example. You can create a one-hot encoded matrix from categorical data using Numpy by utilizing the npi function and array indexing. Explanation. The code demonstrates how to create a one-hot encoded matrix from categorical data using Numpy. One-hot encoding is a common technique used to represent categorical variables as binary vectors, where each column corresponds to a category and only one element in each row is active, 1.